So what is a dunder method? Means like a double underscore method is called as a dunder method. These methods are like predefined and they have some meaning in Python. If you see here, so you can see that a plus b is there. Instead of using this plus operator, we can use underscore underscore add also. Hope you remember in the starting of the programming I told, if you do DAR, for anything, there are two ways. Why we don't use double underscore things? Because they have an alternate implementation. Means when you do a plus operation also, it will be called, right? So the same thing we will use down the line in our methods also. Whenever you define like an add, but use a plus operation, then it will work. In the same fashion, so these are for like basic operations. Like this, there are few other dunder methods. They have like a specific advantage. So they are used for a particular purpose. I will tell those things. So first, if we go through the first thing, which is like a typical addition, subtraction, whatever we are seeing till now. What we know about this plus operation means like, if we have two numbers, you can add it. Either directly or indirectly, the same thing's gonna happen. So if I say D, okay, clear, and Python 01, fine. Whether I did like plus or like underscore underscore add, both are giving same value. So with this, you understood that both are doing the same job. Now, what I'll do is like, I define two methods. Say person, which is a constructor, which we know. Similarly, I define an add. Now what I will do, I create a new class called as like a person. See, person takes two names, right? Name and surname. So I define two things. Now things will be very interesting. So when you're making a call, did you see it is saying underscore underscore main underscore underscore dot person? So any instance when you're calling, it will tell like this only. But when it is printing, if you want it to print in a different way, so we need to use another dunder method called as underscore underscore str underscore underscore. Observe carefully. This will every time return a string. So if I do like a say pass, then what will happen? It will throw an error because it should not return a none value. If you don't return anything, default value is none, right? That's the reason. So you need to return a string, no matter what the value is. Even if it is empty, also fine, but it should come. So when you're printing, say like father instance, you are printing, which is a class instance. You're getting hello. Now, did you mean that, when you're making a print statement, so str is being called indirectly? So now you understood about this dunder method. So whenever you're calling, instead of calling directly, it is called. Or like if I comment this and make it meaningful, can I do like this? Self.name underscore self.surname. Now, did you see what happened? If I call like one more thing right now, say like mother instance. So mother name and so and so. I got something. So two instances were created. So not only this, I can make it much more intelligent by instead of just asking these things, I can make it like, I can make both the values together like a, so, title case. So that also works. Now, indirectly, before even starting the underscore underscore add, you know underscore underscore str. Now the point is, I will try to add these two values. I have this attribute called as underscore underscore mother. You see, when I'm doing underscore underscore add, the other one also should be an instance, same instance. That's the reason I'm doing it. So maybe like if you want, if I can say like is instance of other should be also part of the person only. So then only you want to do, else you don't want to do anything. So then if you see, it works. So instead of you doing like this, I can do the same print statement, mother plus father. the same thing will be executed twice. Did you see? So in the first case, it is very clear. But in the second case, what happened? When you do the plus operation, indirectly underscore add is executed. Now, just imagine, in the previous example, I showed you how many methods are there. For every method you can define, and instead of that method based call, you can use your basic operators. So it will execute in the backend. So that is one advantage of dunder methods. So this is kind of like a method overloading on this, right? So operator overloading. So instead of directly using the operator, in a different way we are using. Similarly, let's take one more example. This time without executing, I can simply tell. If you see in this example, I have a ration number C. See, I have written a doc string. So within the doc string also, did you see? I wrote the documentation. These are called as doc tests. How this documentation is working and all this information we can furnish. So there is a constructor. It is taking two arguments. If you pass single value, denominator will be 1. Then we have an underscore add. You remember, when you're adding two instances of the same thing, we should ensure that both are created from the same one. If not, we cannot add, right? So that's the reason is instance we are checking. If it is not is instance, so then we are trying to create it of the same instance and use it. That is your job. So, but you are doing some operation, so addition and so and so, and finally returning that ration number. So result of this also the same object only. Similarly, subtract also you do a logic. I told already about this str, right? Now I will tell you something about REPR. So generally every method we can define separately. But did you see this is very strange? It indirectly is telling that the logic of REPR and str will be the same. Now, sir, the point, when will str be called? When will REPR be called? I told you already, when you're doing like a RAR presentations, so it will be used. So let's say in this example, see here, you're creating two numbers, you check the is instance, everything is fine. If I do like a plus operation, indirectly it is doing this add only. If I say plus, indirectly it will do add only. If I say subtract, indirectly it will do the same thing, right? Minus, if I do, indirectly it will do the same. So if you do underscore str so and so, or like str of that, means for everything there will not be only operators, right? Hope you remember. Plus is an operator, it has an alternative. But str is a function which has an alternative. Means don't expect everything to be an operator only. So similarly, REPR directly explicitly you can call or REPR of it. Similarly, if you take this example, there is one more example, right? Underscore add. To adding two things. So like that, add, subtract are the very basic things that anyone can understand. That's why I wrote it. Similarly, there is one more operation. I think you never used it, but you wish to use it. Say, if you are doing like a C++ style printing, so I want to do, I use something called as L shift and R shift. So left shift and right shift. So you see, like, so in the end, I have like, a right shift and this one. So like that, I use these dunder methods, right? Now, if you see, I made a call to this call. So, with respect to this instance, you can do underscore L shift, right shift like that. Instead of that, do you think like a C++ style, I did a slash, so lesser symbol. Means this is in fact an operator. So this operator will apply. So when you do less than equal, lower shift, or sorry, left shift. So this will be called. And then you are doing a left shift of this endl. So endl instance, for that you are doing the left shift. So like that, I am trying to say that these are all possibilities. So we can use, so sky is the limit for you in terms of your thought. So next is like, this is very much important. This is another dunder method called as call dunder method. Basically, till now, any class is there, the instance will be there, it will be called, right? So when will the instance be called? So till now, we know all the classes. Every class will have a constructor, str, fine. I wrote like a typical class. You don't know what is this call doing, right? For time being. ignore, and you make a call to this 04. If I ask, did you see that? So the constructor will be called, that is for sure. The moment you did a print, str will be called. Sir, when will be underscore called? So before that, let me tell you so about this concept of callable. Till now, if you go for any class instance, is it called? So when you do this constructor, when you create an instance, constructor is called. When you do like a print statement, underscore str is called. So if you say callable, generally no instance will be callable by default. So here it supports a callable, means like a function attribute. When you do this one, underscore call underscore will be called. So due to that, for a given class, there will be only one underscore call. Did you see this is called? This is called. We'll execute it, right? So that's the point. So in which case we use that practically. Say like if you want to create a decorator. So decorator means what? Passing a function as an input to another function, right? So in those cases, we will use it a lot. So let me go for the practical example. You see, I have written like a count calls. I wrote like, functools.update wrapper of self.function. So basically what it does, this is like a wrapper which can help you in terms of the calls. So basically here you wrote a underscore call. Generally this will be called when the instance is called. So from this, so you are making a call, right? Decorator means you are passing that as an input to this. So due to that, when you are making a call, indirectly it is getting called. When you say like say v, so it is going to this, but this function will pass as an input to this function, right? So that's what the function is passed as an input to this one. So it is passed and it is executing. So number of calls you make, it is making a count of it. So call is making a track of how many calls are made to it with respect to this variable. But did you see in which case we are using? So like this call dunder method is very useful whenever you are creating any decorators. So class based or function based, method based or anything. Next, so coming to the differences between str and repr, you already know. Similarly, if you go for like repr, there is one interesting problem that it solved. Generally, if I go for this example, if I have see this thing, okay, I have an repr, I have an str. Instead of defining twice, you can assign the same thing. Then whatever is defined for repr, the same thing will come. So generally, when you're printing this value, so when you do a print, so str will be called, right? Underscore str underscore is called. But when you do like an string, or like if you do any operations, so repr only will be called. So when you do an repr, so here what happened in this case, you got like a range of 50, means 50 values are there. So whenever you have a large values, it is coming all the values like this. So what if you're doing a db operation? You're gonna let like thousands of values, right? So you cannot make all the things to be printed when you're asking to check. So in fact, this is the same problem which many ORMs, next I will tell about that concept, when connecting with the databases, we call ORMs, object relation mappers. So whenever you have a large data, when you're printing, if everything is printing, it would be difficult. Rather, you can tell like, give the first 5 elements, dot, last 5 elements. Users also can understand, right, what's happening. So I like this. If you want to make the representation of the output smart, you can use something called as reprlib, which is a built-in module. So what you need to do is like, so just whatever the items you want to print, instead of printing directly, so or returning directly, you return like this, reprlib.repr of this one. Generally, repr is for like representations only, right? So if you want it, generally you can get the true values. So if you do like this, what will happen? And if you print, it will not print the entire value, but it will only print the part of it. It will only print the part of it. Did you see that instead of printing the entire value, it will just print this only. So it is more advantageous for us, right? Similarly, so this is one of the advantages that you can get. So that's the point of RAPR. And in fact, you need not do it. So when you do like a print itself, it is working. When you do print itself, it is working. So RAPR is working because here you didn't write an RAPR, STR. So it's working. And one more thing, this is called as like a STR RAPR. This is one of the interview question, the most common IKM question. So the point is, when you define like STR and RAPR for a particular class, you do string formatting, right? So during string formatting, this is like a exclamation S. So means only that attribute it will go and call and execute. So, when our STR is called, testing will come here. When our RAPR place is executed, it's gonna give programming. So that's why it is called as testing programming. So testing programming. So testing. So programming. So you got the single instance only. But within that instance, if you want to call like this, it can give that kind of flexibility for us. So if I go further, yeah, so there is one more interesting thing called as context manager. This is also like most important thing. If you take this example, context manager, how do you manage the context? So this is very, very important. So typically, when you open a file, you open a database connection, you open a socket connection, you open anything which is costly enough, you should follow these things. See, if you go for a file, typically what happens? You open a file in a write mode, read mode, or whatever mode. You do the what are the operations. Then you finally close. Why everyone is saying for you to close? Because if you don't close, garbage collector will close it. But in the process, it can delete few of the things. So to avoid that, we do a flush and close. And also it will occupy some memory, right? You don't want to use that. So once your work is done, you want to release. So this is all the point. So instead of that, if you remember, in file operations itself, I told something called as a with statement. If you do like a with in the backend, it is indirectly doing what? Like a try block, so plus finally block. So it is making that together and ensuring that it whatever the handler you have, this one, it is kind of like closed. So it will ensure that. So you need not worry about closing. So the moment you come out of the context, it will close it. Sir, what if I want to create a similar kind of open in like for us? So in that case, you can create like a small, in this case, in that case, we can create like a class. So instead of like an open, I created like a manage file, something. I created a class. Same here also it takes a file name and the mode. I wrote like a file name and the mode. So mode is like read by default, and I'm taking both the things. So fine. So next, if the user is asking to print whatever is the value is there, then I'm defining some REPR so that whenever the user calls, they will get it. Now the point is the user can make a call directly or indirectly. Say like if you make a direct call, it makes no much difference. So if I execute it clear and Python 06 so and so, it will say like, this is called REPR, it will print. That file, so and so file is called with something mode. Now the point is, I wanna do the same things in a slight different way. So instead of directly doing, with a context manager, I want to do. I wrote like a context manager. The context manager is very simple. Whatever the instance you want to create, instead of writing equal to that instance, you write like this side. So it will ensure that this is closed at the end. So everything is happening. But sir, there is nothing like a close to define, right? So then what will happen? Will it execute in the same way? No. What is saying the attribute error? Enter. Who is asking? So with is asking. Means when you define any method like a with, it should ensure that that particular class has underscore underscore enter defined. Only when underscore underscore enter is defined, it will work. So if I write Let's say here we want to do a file operation, right? Let me do that in a enter method. Within the enter, I'm opening that actual file and I'm passing that file handler. Now we see it works perfectly. Now it is saying one more thing. Hey, I entered with whatever the enter is giving, with that it will enter into it. So the moment you are doing a with, so it is entering into the context means it will go into this. When it is coming out, it need an exit also. That's what it is defining there. So generally for exit, whenever if exit is there, for that these are like the default values you need to pass. What is the exception type, exception value, exception, so trace back. So these three values will be like an input. So if you don't want to use, ignore that, but they will be like standard input. So you want to do a file close operation. You did it. Now did you see it worked perfectly? So whatsoever you do, it worked. Means if you want to use with context manager, you need to define these two methods. Enter method for logic to execute the moment it comes inside. Exit method, so the logic to execute when it is going outside. So this is all about it. And similarly, if I go the same thing, there were like multiple examples. Just I want to bring to your notice. You see here. So if I do like a enter and an exit, if I say C equal to CM, so with C, I'm doing some logic. So the moment you use with, it will go to the enter. The moment you come out of the context, exit will be called. So like multiple examples I gave for you to understand. This is all about the context manager. So similar to the context manager, we can also create the iterators. Hope you remember about the iterator object. Iterator objects are the disposable objects. Mainly we created iterator objects on the iterables. So hope you remember. So when you have any object, if you pass to a iter built-in function, it becomes an iterator, right? If you pass like any built-in function, if I pass to the iter built-in function, then it will become an iterator. Is if I say clear and Python 07. Did you see what happened? So what are the values are there? As you pass to the iter built-in function, you are getting the iter build list iterator. When you're asking the values, you got the first value, second value, third value like this. Every time the next iterator. Now, if you want to create this kind of custom iterator, then we need to define two methods. So for this, it expects something like this. See here, constructor is there. So it is optional for you, constructor, whether to use or not, but in this case, we need it. So there is something called as iter. So where whatever the values you need to what, and next is one thing. Whenever the users are asking the values, how to give it. So you want to loop over each other value and give it. At one stage when you don't have value, you want to raise a stop iteration exception. So this is how you can define a custom iterator. So you pass an iterator, same like how you executed like an ordinary list passing to iterator and getting the next values. You can do the next built-in function on these things and get. So like this, whenever you're working with large values, or let's say you are working with a file containing large amount of data. So you cannot read all the data. We can create like this class with a iterator and you can read the data. So you can take that as an assignment. And next, we have something called as slots. So this gives like a unique question to everyone. Slots tells that whether a class is mutable or not will be very much helpful. So what is the point? Say if I go for like an ordinary class. So till now, I assume that I have a class. Okay. I have a ordinary class. I define some two variables. So if I say vars means what? It will give the list of instance variables, right? Like a dictionary it will give. That is vars. So, okay, ignore this one for a moment. So yeah, if I execute it, what will happen? Whatever is there, like a foo has a value of none, bar has a value of none. Why? Because you defined as none. So that's why it got it. Now, subsequently, if I'm trying to assign a value to it, so there are two ways of assigning the values, right? So using the direct assignment or like set attr, which is a built-in function. We give the instance, what is the attribute, what is the value. So if you do like this also, indirectly the settator will be called. These are the two ways when we can make a call. Subsequently, after making this call, if you ask, hey, what is the vars again? Did you observe now? That is having the extra attributes. Now, what I'm trying to prove here is that when you're defining, you defined only two instance attributes. But subsequently, after creating the instance, you added these things. Now, the point is like, if I create like another thing called as O2, and for that O2, if I say vars of O2, if I ask, will it get all these values? No. So that is pertained only to that instance. But point is, after creating the instance also, we are able to add the values. Hope it is clear till now. So for everyone. So you can say like, is an instance mutable or immutable? Kind of immutable, right? Now, if you want to restrict these ones, so that's where we need to go for slots. Slots, what it does is that after creating an instance, subsequently you cannot change the values. So let me show you this example. In the slots, you have defined like foo and bar. So within that, you defined foo and bar. And after, along with that, if you define anything else, it will throw an error. Means even if you define within the class definition also, any attribute apart from these two, it will throw an error. So slots will try to limit. It won't allow to create dynamic attributes. Not only dynamic attributes apart from that here within this also. So that is the point about slots. Similar to the slots, we have one more thing. So the other Dendro methods, yeah. Hope you remember previously I gave an assignment also on this get address and get address. So this is like a descriptors. So what it does is that simply for you to understand, get attribute. If you are asking for a particular attribute, then it will give it. So underscore underscore get underscore underscore get attribute. These two are there. You try to understand the difference. So I created like a DB instance. I'm asking vars. So, vars built-in function can be asked directly or indirectly with underscore underscore dict. In fact, both way we can ask. That's why vars function we can apply to objects which has underscore underscore dict defined only. Others we cannot ask. So the point is, when you're making a call, it will be called. Say, if I comment these ones, you can walk through that. Clear and Python 09. You can see initially what is the existing value of thing. It will get it. Subsequently, you are asking foo dot get dot foo. The moment you are asking a foo, so it is going what? It is trying to get the value and set the value and get it. So what is the so foo is not there at all, right? So foo is a new attribute which you didn't define. For the first time you are defining. So any attribute. Generally, what will happen if this getter is not there? If this foo, if you are asking directly, what will happen? It will throw an error, right? Because hey, you defined only exists. If you are asking foo, how can I give? If you want to avoid that kind of issue where someone is accessing a so invalid attribute, but you don't want to throw an error, in that case you can define this one. Then what happens? No matter so what user asks. Let's take the example of other things. First of all, say like exists. If I ask exists, so for like exists is already present, right? As the name is saying. So exists is gonna give the value. So exists means value for exists. You are getting means whether it is for like a already existing or new attribute. Whenever you are accessing either of these things, if you see observe. So if you are access exists for exists also it is saying value for exists. It's not saying like self dot exists equal to 5. Why? Because get attr if it is there, it will be called. So called for like both. Called for all. So get calls for attributes. Attributes. So whether present or not, whether present or not, it will be called every time. And after that, if I say DA, so dicts, did you see that exists is also there? So similarly, if you see exists, oh my God, I think I did a mistake. I should have asked the exact thing. Okay. Yeah, my bad. You see now? Oh, if it is like a new one, a existing one, it is not called. So if it is not present, when not present, when not present. So when it is present, it is coming directly. It is not going to this one. So 5 only you are getting. When it is not present only, you are asking. Fine. So fair enough. So now, similarly, delete atom. As the name it is saying, the moment you are trying to delete it, it will be called. So these are the descriptors. And similarly, we have like get and underscore set also. Get set. So as the value descriptors, what they're saying. So when you are asking to values, get will be called. So when you are setting the values, set will be called. Now I will leave that last point for you. You need to help me. What is the difference between this get attr and get, set attr and set, like that? So, and there is one more last point. So within this Danda methods, there is something called as functools.total ordering. So if you know, basically for any objects, if you want to define all these values, so if I define like a total ordering, I have defined an init. I defined like less than, equal to, and REPR. But did you see that I'm asking all these attributes? Did you see? When I do less than, I defined less than, so I can ask. Greater than, I cannot ask. If I remove this total ordering, which is coming from functools, if I execute this 10th value, then it will throw an error that, hey, I don't know what is this less than or equal to. It is not defined and we cannot, this doesn't support it. But when you do a total ordering, so all these attributes will be automatically evaluated. How? Because it will implement these things in the backend for us. That is the concept of total ordering. So whenever you have an instance, and if you want to add all the attributes to it, so this is one case where it will be used. And the last point, this is like the most important point. So within this classes is about the new method. Very few people know about new. So the point of new is very interesting. So till now, we know that there will be a constructor. The constructor will be called the moment an instance is born, right? So this is what the story we know till now. So there is a new, there is a init also. There are two things. So the moment an instance is created, which will be called? Till now we know that. So it will be definitely the instance will be called. I am born, I am named. So see the sequence, you will understand. In the backend, in fact, this underscore new, did you see that it is taking an input of CLS? Means it's like a class method kind of thing. So, and it is saying that the CLS will be called. Why? Still now we know that constructor is called. So that's the point. First, the instance is born, then it will have the basic attributes assigned. So when it is a similar analogy, if a person is born, first the person is born, then you will name them, right? So born is already happening action. So why we need to have this new? Generally, you don't use it. So if you want anything to be happening during the born, means if you want something not to be born, or like when is born, we want to do something else. So there were strategies like whenever, say, if you want to go for a singleton pattern. Singleton is a design pattern where if an instance is already created, you don't want to create it. Either you want to use an existing instance or you want to throw in error. In those cases, this new has a sense. But the general recommendation is to avoid these confusions, don't write new and init in the same class. If you write, definitely new will be called, not the init. So then it leads to a lot of confusion and chaos. Until unless you need it, you don't do. Sir, can we go for a use case where it will be used? Yes. So if I go for like, as I told about the singleton pattern, let me explain that. Singleton means what? So till now we have a class. From that class, you create an instance. That is what we know. But if you create like a second instance, third instance, many things we can create. But if you want to stop that, we can go with this. If you see this example, here I defined like a class level variable, like a flag. The moment when you are calling the instance in the constructor itself, I am checking. If already this was there, you raise an exception. You don't want it to call. So the first time when they call, it works. Next time subsequently when they're calling, it will go to the constructor, right? It will execute. But if you want to stop it at the new level, means instance level itself after born before itself. Using new also you can do. See, like in the new you passed it, you are checking the has attribute and you are doing it. So like this also you can check. It is simply checking at the class level whether the instance is already born or not. If the instance is not born, you want to use it. If it is born, you don't want to use it. So the singleton pattern can be implemented in different ways. So this is one way of implementing. The alternative is like this. So you define at the new level or at the constructor level. So that's it about the Dunder method.